Okay, in this episode we are going to learn how the memory is organized for an array elements. So for checking the memory organization of array elements, here in this example I declare two variables. First one is an integer array that containing 4 elements. Second one is a float array that containing also 4 elements. Okay. So now here I am going to print out the memory address, memory location and the value of these two variables. So we have to start a loop. So for working with the loop we need an integer value. So I declare an integer variable I, and here the initialization of this variable is start from 0. And now these two variables, two array containing 4 elements, so we can put our condition like this: I less than or equal to 3. This is because every array is count from index 0. And now I update the variable. Okay, now here I am going to print out the memory location and value present in these two variables. So first here I am going to print out the memory location and value of the integer variable. So use a printf statement. So put a new line. Now we have to print the memory location first. So %u equal to, now we have to print out the value present in that particular memory location. So %d. First is the address. So we have to get the address of each element present in the array. So use the address operator and use the variable name and use the index. Okay, so this will print out the memory location of each variable, each elements present in the first integer array. And now we have to print out the value present in that array. So use n of I. Okay, so we have to print a message here, printf integer variable details. Okay, now we have to print out the memory location and address of the float array. So use a printf statement here. Here it is. Float variable details, integer variable. Okay, now we can check the program. So here I'm going to compile the program. Yeah, the program not containing any error, so we can run it now. So I run the program. Now from the output we can see that the memory locations for these two variables, the memory organization for these two variables are contiguous. That means the variable memory allocation is not random. Each elements are allocated in adjacent sites. So in the integer case, the first location is 96 and increment by 4 it is 0. Now 4 incrementation, now again 4 incrementation. In the case of float value also the location is contiguous. Okay, so in the case of an array, the memory organization and the memory allocation is contiguous. Okay, this is a very useful concept while you passing an entire array to a function in a C program.